Hello, hello, and welcome to the Mastering Number program. There are literally thousands of schools out there and tens of thousands of teachers who have joined the program. So a huge welcome to you all. I'm certainly very excited about it. Um, so in this presentation, we're going to look at the aims of the program. What are we trying to achieve by it? We're going to look at how the program is maybe different and the key strategies that are employed to make it effective. And we'll look at the development of sustainable change in your school. Your school will be putting a huge investment into this program, and obviously you want it to make a real difference to your pupils. So the aims, kicking off with the aims. We want to develop fluency in number facts because that will make a huge difference to children's progress in mathematics. And alongside that, we want to develop a number sense, and that's a flexibility with number where children reason, they see relationships, they see mathematical structures, they see such things such as if 5 and 2 is 7, then obviously 7 minus 2 is equal to 5. So they're looking for those relationships and embedding those relationships, which will not change in Key Stage 2 and indeed in Key Stage 3 and beyond. So that's really important. So fluency in number facts and that deep understanding of number, something which we call number sense. So let's just think about a child in your school, a child that struggles with maths. I'm sure you've got plenty of them. To them, mathematics is an enigmatic subject. It's a mystery. Some just seem to pick it up so easily, while others seem to really struggle. Those who fail, in fact, in this research by Tall and Gray, they found that those who are struggling and indeed failing are doing a different type of maths which is harder. It's unconnected, it's not fluent, and therefore no wonder they're failing. One of the key characteristics of those that are failing is that they're counting. The only strategy is to count. They're not seeing those relationships. They're not making those connections, which will make the maths easier. The example I just gave you, 5 and 2 is 7. Therefore, 7 minus 2 is 5. I know one fact, 5 and 2 is 7, and I've got another fact for 3. It must be 5 because that's the relationship within the mathematics. So the answer is don't count. And certainly we will be developing that as we work through the program. And going on then, Tall and Gray talk about this over-reliance on counting. And not only is it making the maths more difficult, but it's also inhibiting flexibility, thinking, developing concept-based problem-solving strategies. So as you can see, it's not just affecting calculation, but it's affecting mathematics much more widely. And we need children to have stopped counting by the time they move into Key Stage 2 at the end of Key Stage 1. And that's why the program is based on reception Year 1 and Year 2. So to summarize then, that over-reliance on counting, it's associated with low attainment in mathematics, and it restrains that flexible thinking and impacts and inhibits the ability to problem solve in mathematics. So these are really important things that children need to grasp early on. So the good news is that low attaining children can develop the characteristics that we see in high attaining children, those characteristics that make learning successful that Tall and Gray talked about. The research has been done. Futsina and Anne Watson are a couple of examples, and in their research, they showed that that actually with direct teaching and explicit support, that actually all children can think mathematically, make connections, see relationships, which is good news, and the program will utilize that fact. So to summarize then, the good news is low attainers can develop the kind of thinking associated with higher attainment in mathematics, but they need the explicit teaching. Having said that, this program is not just for low attaining children. The program is for all children, because actually thinking about mathematical relationships, having the opportunity to develop the automaticity is important for all children and then will enhance all children's progress. Daniel Willingham, a very famous cognitive scientist, talks about the importance of automaticity in knowledge of number facts in the context of mathematics. And he makes a couple of really important points. One is that actually when we know those facts, when we just know that 5 and 3 is 8 without having to think about it, it frees the mind to think about concepts. It's not getting in the way. It's reducing that overload. And very often, low attaining children are just overloaded. It's not that they can't learn. It's just that there's too much going on at one time. And that retrieval and that automaticity is really important in the context of problem solving. And don't we want all of our children to develop the ability to problem solve? It's really central to mathematics. So just to summarize again, that automaticity with facts, it relieves all overload and it supports problem solving. Key things for all children. So how's the program different? What are the key features that will really make a difference and make it effective? The first one I'm going to talk about is differentiation. The answer to that is there is no differentiation in the program. A sharp intake of breath, maybe. Not in the traditional sense that we think about it. Because the aim is to provide the same experience for all children. One of the things you might find is you might think, gosh, the pace seems really slow. That's deliberate. That is deliberate, and it's not just for our low attaining children. It's to provide the opportunity to really have the time to think deeply about mathematical relationships and time to practice to really embed and develop the automaticity. And we're looking at developing a mathematical mindset that in mathematics looks for structures and relationships. No child will be bored in a lesson where structures and relationships are valued and they are looking for them and sharing them and thinking about them more deeply. The materials do, however, contain follow-up activities for children who might need more time to practice, more time to embed. So that's the approach we've taken to differentiation, is that we'll give some children just a little bit more time in order to achieve the goals within the program. And in particular, the reception materials, they include suggestions for small group work, for routines, and for continuous provision. It is important that reception children, that our youngest children, have that time to really embed the key ideas that they're learning about, to play with those ideas within their environment. So focus is really important. Let's just now focus and think about how would you make 14? If you had a rekenrek, there's a rekenrek, I'm sure you'll recognize one by now. If you had a rekenrek and I asked you to show me 14, what would you do? Would you show me something like this, with a 10 on the top and a 4 on the bottom? Or would you show me a 4 on the top and a 10 on the bottom? Or maybe you might be thinking, I'll do 7 and 7. I know double 7 is 14. And show me this bottom image. Now you might be thinking, does it matter? Surely all of those are valid ways of representing 14. And you're right, they are. But what I didn't tell you, in my particular lesson, I want to focus on place value. I want to focus on what we call the 10 and a bit strategy. And so actually what I'm looking for is this top image. And I want everybody to focus on that top image. If we have lots of images going on around the classroom, then for some children, that's too much. It's overload. They'll only think about their own image. They won't think about everybody else's. It's just too much to take in and learn and embed in any meaningful way. So the focus on one thing at a time is really important to provide access to all children. And in this particular lesson, as I said, I'm going to focus on place value, and I want children to see 14 as 10 and a bit, 1 10 and 4 more. You might say, well, surely this second image is okay. No, it isn't actually, because a child might do that, and but I will pick up on it, because actually they might do it because when they say 14, they say the 4 first, 14. And therefore, you might say, well, it's still 14. I've got a 4 and a 10. But actually, it does matter which order they come in. Because when we write 14, we write the 1 first. And we need to understand that that 1 represents 1 10. And then we write the 4, which represents the 4 more. So 14 is 10 and 4, a really important structure for moving forward. We will look at double 7 in another lesson, but not in this particular lesson. So this focus requires that we draw attention to these really key aspects of mathematics. And I think in the past, many children have ended the lesson and they thought about different things. And we might say, well, that's okay, that's inclusion. It's not inclusion if actually some of the children are thinking about the less important things and they haven't picked up on the most important thing. So if you look at this image, I expect you're saying to me, well, it's 6, isn't it? It's 6. One of the questions I'm going to ask you is, how do you know it's 6? And what answer do you think I want? Okay, just pausing a minute for you to think about that. I certainly don't want the answer 3 and 3, even though it is correct, because I've deliberately chosen this image and used a rekenrek, which highlights the 5 in order to focus on that 5 and a bit structure, which is really important for children learning number facts and making progress. We will, on other occasions, look at 3 and 3, but we'll probably look at it in this way, with 3 on the top and 3 on the bottom, and see that that's a double. But in this particular lesson, I want you to focus on the 5 and a bit structure. I think children are often think, I'll give a different answer that nobody else has thought of. But in the Mastering Number sessions, we are drawing attention to a particular mathematical structure, and we want all children to focus on that in order to be successful. So I've just talked about 5 and a bit there, but of course, before we get to 5 and a bit, we looked at 5 and a bit on our rekenrek. But before we get there on our rekenrek, we want to look at 5. And the year 1 materials start off by looking at the composition of 5. Reception materials, you're probably wondering what happens there. They don't start with the rekenrek, they start with subitizing, and I'll move on to that. But they will at some point during the year start using the rekenrek. So in year 1, I'm thinking about 5. I'm going to ask the children to do 1 push 3. That 1 push is really important because I'm seeing that 3 as a unit and I'm not counting. Children from the age of 2-year-olds can actually subitize 2. They can see 2 without counting. 3-year-olds can subitize 3. 4-year-olds can subitize 4. You might be thinking, I'm 49. I shall be able to subitize 49. No, it doesn't work like that. It kind of ends at about 5 there. So 1 push 3. How many more to make 5? I can see the 2 here. I know there's 5 red. So it's 2 more to make 5. Yes, well done. 1 push 4. How many to make 5 this time? 1 push to make 5. One of the early learning goals is that children should develop automaticity in number facts to and within 5, with a few others added on. They won't learn those simply by using flashcards until they can't forget it. Instead, they will learn it by looking at the structure of 5 and seeing that 3 and a 2 partitioned in that way. We're going to use something called a Hungarian number pattern. And for children, we'll probably describe it as a dice pattern. And again, that's looking at structure. So the structure is a bit different from on a rekenrek, but we look at this one and then we apply it to a rekenrek as well. So I might ask you, what can you see? And you can see 5. You can see that 4 of them are yellow and 1 is red. So we're learning the structure that 4 and 1 is 5. And hopefully you didn't have to count them. You recognize the 4 around the outside in the square pattern and then the 1 in the middle, which makes 5. So we don't just use the rekenrek, we do use a variety of representations. The ones that actually we feel best represent the structure of the mathematics and can help and support children in their learning. And this is a very common way that children learn number facts in Hungary. So we know it works, and we thought we'd incorporate it into the program. Here's a little video for you, a little treat. Number block 7, again, for those of you who don't know, I work on the CBeebies number block program, and I'm very proud to say that. We did win a BAFTA, by the way, but it's a fantastic program, and number blocks very much wanted to support us in the program. So we have images and little video snippets and things. So here's 7, and 7 says, "Can you find the 5 in me?" No, say the children, there's not 5, that's 7. But actually we need to deepen their understanding of the composition of number. The inside numbers, there are other numbers. Our pilot program, which we ran in the summer term, showed that actually for many children, this was something that they really developed, understanding of composition. The inside numbers are other numbers. And of course, knowing that enables us to develop that fluency with number bonds. So let's just have a look at the children finding the 5 in 7. Here we go.
Okay, what number have we got here? Can you make it on your rekenrek? Well done, Thea. Well done, Mila.
I can see the 5. So I got the 7. Take away the 2, and here's the 5.
Okay, here's 7. So 7 is made of 5 and 2. Can we all say it?
7 is made of 5 and
2. Very good.
Okay, I'm sure you noticed the little girl there with the glasses, and you could see her number sense. You could see she made the 7 on her rekenrek, like that, and then she said, where's the 5? If I take away the 2, there's the 5. So she was able to see that 7 is made of 5 and 2. You'll have noticed in that video that the children used what we call a stem sentence, a sentence that they all said in the same way together. They only said that sentence once they understood the mathematics that was going on, and then that sentence was used then to help embed and commit that fact to their long-term memory. We will use stem sentences throughout the program, and we found them to be very effective on the mastery program. I remember one teacher said to me, "These stem sentences, Debbie, they've just leveled the playing field. They give all children a way of talking and indeed thinking with clarity about the mathematics they are learning." Here's it animating, and we can see that 7 is made of 5 and 2. So still thinking about this, drawing attention to. Okay, what can you see now? What can you see now in these two images? Just give you a few seconds to think about that. If you've got somebody sat next to you, have a little conversation. Okay, so on the first one, you probably said, I can see 2 3s, I can see double 3, I can see 6, indeed. And then on the second one, you might think, well, I can see a 3 and a 4, and that's 7. What we want children to see is that actually it is double 3 and one more. So that's a strategy they're using for working out that 3 and 4 is 7. If 3 and 3 is 6, then 3 and 4, 3 and 4, 3 and another 3 and one more must be 7. So it's those relationships that we are focusing children on and supporting them in being mathematically observant and going back to that number sense again, reasoning and making connections to the double 3 and the 3 and 4. There. Okay, continuing with this focus and noticing, we can see in the two images, what do you notice? I'll just give you a minute or a few seconds to think about that. What do you notice about these two images? What's the same? What's different about them? Okay, so the first one is double 4. And in this particular class, some children made double 4 when asked to make 8 on 2 rows. That's often a favourite of children. They pick up on the doubles quite quickly and more easily than some of the other facts. The child on the right-hand side, however, has made 3 and 5 or 5 and 3. And I'm just going to and what he's done is that he's conserved the number. We'll look at him explaining in a minute. And what he's done is he says, well, I thought of 4 and 4, and then he said, I first did 4 and 4, and then I took 1 from one of the 4s, and I added 1 to the other 4. So he's conserved that number, and he knows, even without counting, that 5 and 3 is 8. Because he's conserved by adding 1 and taking 1. So he's used that mathematical relationship, a relationship that we use a lot in mathematics, not just in the early years, but as we progress through into Key Stage 2, a calculation such as 274 minus 57, we say, you know, so we put it into column method. 4 takes 7, we can't do that, so we need to exchange and bring over a 10 from the tens column. So what we've done is we've changed 234 into 220 and 14. It's still 234, but we've just rearranged it and transformed it by partitioning it in a different way. Let's just have a look at him explaining his explanation. I'm sure he'll do it much more clearly than I did. Here we go.
Jack has done this. Why did you do that, Jack?
Because if we did 4 and 4 and we minused 1 from the 4, we'd make 3, and if we added 1 from the 4, we'd make 5. So 5 and 3 equals 8.
Very nice.
Okay, thank you, Jack. That's very helpful. Okay, just a little bit a word about reception. The reception Mastering Number program will cover quite a significant proportion of the new EYFS framework, and it will certainly provide developmental progression for much of the early learning goals. So it may be, although we've said this program is in addition to your main lesson, in reception, sometimes it might replace the main lesson, and it's up to the teacher to decide when it can do that. Also, as I mentioned previously, the reception materials provide suggestions for continuous provision for small group work and routines to model that good early years practice. So the Mastering Number program will only be 10 minutes, and then there needs to be opportunity to embed the ideas and for children to play with them, explore them within their environment. We're now going to watch a short video with some reception children engaging in subitizing activity. We'll say more about subitizing in a few minutes.
Right, ready? Fast eyes, ready? Ready. 1, 2, 3. 1, 2, 3. 4! Isabel, how did you know it was 4?
Because a minute ago I did 4 and I thought 2 and 2 and then Edie.
We've already seen number 4, haven't we, when we were doing the dice pattern? So what do you see? Tell me what you see.
2 and we could have 2 and 2 is 4.
So we got a 2 and a 2 and it equals 4. Yes, it does, Isabel. Fantastic.
Did you notice how the teacher had arranged the dots? She's arranged them into 2 groups of 2 and in a rectangular pattern. Children are becoming familiar with that pattern and using their spatial reasoning, associating that with 4. Also, as we said earlier, children as young as 2 can subitize 2. So they're seeing the parts within the 4 and bringing those two groups of 2 together and recognizing that 2 2s are 4. This is how children will develop their automaticity with number facts, not by flashing facts in front of their faces, but instead becoming mathematically observant, recognizing mathematical structure and seeing mathematical relationships. You'll have noticed in the video that the children became very excited and wanted to be the first to shout out that there was 4 there. You might want to think about how you manage that with a whole class. So you've got you flash the 4 up on your screen at the front. Everybody sees it. But then instead of wanting call out, you insist that there's at least 30 seconds of silence to give all children the opportunity to process what they saw, to see it in their mind, to have it ready on their fingers, and then after a count of 3, they show you that 4 on their fingers. So there is an awful lot of research around subitizing, which is why it's come into the new early years framework as one of the one aspect of the early learning goals. Barodi and friends talk about that children are sensitive to quantity. They're born with this ability and this sense of numerosity, but they need those interactions in order to develop their subitizing skills. It doesn't happen by itself. And in particular, children from low income families or low resource communities often lag behind in subitizing, and children also with special needs. And they actually say that harms their mathematical development. So subitizing will play a key role, particularly at the start of reception, but also in the other year groups as well. It will be developed as is age appropriate. So inclusion for all children. So I'm just going to show you 3 statements and I'm going to put them all up on the screen and then give you a few seconds just to look at those. Okay, so what are you thinking? How do we include all children? Here's 3 potential approaches. First is that children are included through an open approach, which allows for lots of responses. And I know many schools have used that in the past. Oh, that's your idea, that's your idea, that's your idea, that's your idea. One of the downsides of that is we get lots of ideas all at once, which can for some children be overload, and all they want to think about is their own idea. They haven't got the time and the space in order to learn new ideas. Approach B, there's differentiated questions which are aimed at specific children. Oh, I'll ask this question and it's really aimed at my higher attainers, so I'll look out for my higher attainers to give me a response to that, and I'll ask a simpler question and I'll look for my lower attainers to give a response to that. Potentially that could work. The only problem is that those expectations often become self-fulfilling, so those who we think are higher attainers do make better progress than our lower attainers. Or is it C, the attention of all is focused on the one mathematical relationship to reduce that load, and then those distractions are reduced. So everybody's focuses, their attention is drawn. There'll be a lot of development of executive function, children's ability to focus, that will work through in the program and make sure that all children are seeing the same thing and becoming mathematically observant and noticing what's important for them to notice. So the approach we're taking is in fact C. And the other thing we're doing is that we're slowing down. You may think, oh, my children can already do this. This seems very slow. We need to quicken up. I would ask you to resist that, because I know as teachers you have all experienced, you come back to a topic and you start the topic and you think, gosh, I taught some of this last term. Where's it gone? It's just disappeared. They've not retained it. And one of the reasons is that it wasn't taught well enough, or the children didn't have time to embed in the first place. And so this mathematics that we are teaching is going to be of use to them, as I said, Key Stage 2, Key Stage 3 and beyond. So we need to slow down, and by doing that, we'll stop that reteaching. We won't have to reteach, and in fact, in the longer term, children will make better progress, slowing down in order to go fast. Ofsted, in their latest mathematics review, I've just pulled out 2 points. There's a lot to support this programme within there in terms of principles. They talk about needing to balance introducing new content with pupils' need to spend time revisiting content. So one of the key things that they think is important is that time to practice, that time to retrieve as well. I'll talk a little bit about retrieval in a few minutes. It explicitly says pupils should not be rushed through content. I think the focus on we're looking at mathematical relationships means that actually nobody's going to become bored. It's not just about knowing the answer, but it's about making connections and seeing those relationships. And that focus will make it relevant to everybody. In East Asian countries, there appears to be little differentiation. We've used differentiation a lot in the past, and we did it with good intention. Our intention was these children seem to need longer to do things. So we'll slow these down in order to catch them up. When the reality is they never catch up. The gaps between reception and year 6 don't narrow, they just widen. And we need to stop that. And so that's why this programme has taken this particular approach. So I said I would mention a couple of key things here. Opportunities for retrieval practice. The cognitive science tells us that that's really important, that actually children need to regularly think about and retrieve the knowledge and understanding that they have. And so that retrieval practice is important, and will provide exercises and games to engage children in that retrieval practice within the programme. And the other important thing here is, well, it's 2 things that go together really. The importance of developing spatial awareness and also visualization. So that's spatial awareness, where 6 sits in relation to 7. That spatial awareness, you saw those reception children seeing that 2 and 2 grouped together, and together they combine to make 4. So again, an area which is really developing in terms of realizing its importance in learning mathematics. And that visualization, we want children not just to be using rekenreks, but to be visualizing rekenreks, to be able to visualize what that 6 looks like on a rekenrek without having to move it and see it, to see it as that 5 and a bit structure. And the process that happens in terms of developing automaticity is that children's doing, seeing, noticing becomes a visual image, and we will talk about scaffolding them to move away from using the rekenreks. So we'll be planning, although the rekenreks are very exciting, we want you to use them, we'll also be planning for actually moving away from them so it becomes a visual image. And that repeated thought with regard to that visual image, for example, on the rekenrek, I'm going to do 7, add 4. There's my 7. I'm going to add 4. So I'm going to partition my 4 because I want to get to 10 first. So 7 and 3 is 10. 4 is 3 and 1. So I need another 1 here. Okay, so that thought then, that transfers to the mind, and being able to visualize the rekenrek are 7 and 4. Yeah, add 3, that gets me to 10. Oh, and I need 1 more. 7 and 4 is 11. That repeated thought and reasoning about the connections will eventually fade, and I just go 7 and 4 is 11. If you want me to unpack it and retrieve it back, I can do that. It's in my long-term memory, but actually I don't need to anymore. I've got the automaticity, which is really going to help me make progress in other areas of maths as well. So my last section now I just want to focus on before we finish is that developmental sustainable change in your school. The Mastering Number Programme is a new initiative to your school which needs careful thought and planning for. I'm going to highlight, many of you will be familiar with this. This is the EEF framework, which is about putting evidence to work. It's a school's guide to implementation of any initiative. And it has 4 phases: exploring, preparing, delivering, and sustaining. So we would like ask you in the exploring stage to get started with that straight away. Think about, okay, we've tried to develop fluency in the past. What have we already tried? What have we learned from that? What are our school priorities, and how does this development of fluency fit into that? Because unless it's part of your school priorities, then it's likely not to have the impact that it potentially could have. At the preparing stage, consider your current provision. Do you need to make any adaptations? For example, what are the core representations that you use? For many of you, the rekenrek will be new. Are you going to replace one of your core representations with the rekenrek, or are you going to run it alongside your other core representations? So something for you to think of that will personally be bespoke to your school. How will you ensure all staff have the vision, even for those not involved? Key Stage 2 teachers will need to know about the programme because they will be receiving the children as they come through. Timetabling. When are you going to fit it in? Are you going to maybe shorten the main lesson slightly, maybe by 10 minutes in order that you can free up some time? Or have you found a space that actually, no, we can do it then, that it'll fit in then, in addition to, we won't take any time off the main lesson. What I would recommend, however, is that you don't just tack it onto the main lesson and use it as your starter. I think because of the intense focus it requires, I would do it at a different time from the main lesson in the day. We have planned it so that it will more or less fit into the curriculum for most schools, so that actually you're learning this in conjunction with what's happening in the main lesson, because what we want to, a true mark of whether it's being successful is our children bringing in the mastering number. I wouldn't take anything out of your curriculum that you're going to teach in the main lesson. This is deliberately in addition to provide that additional practice and focus for that. So you then get into the delivery stage and critically reflect, how's it going, what's being successful, what's being not so successful, what can we do about that? And there is a requirement that you engage in the online community where you share your challenges. You will have a work group lead, an expert in mathematics who will support you within that community. But also you share your successes. This happened in my classroom today. I can't wait to tell the rest of the group. And so there'll be a community that support each other with a work group lead, which will be local to your particular maths hub. And we suggest that you go on there at least once a week, and that will be monitored, because it is an important part of the program. As you get towards the end of the year, into your sustaining phase, questions to ask: how will you sustain and refine the development that you've had this year, and how will you take the program into next year? This isn't a one-year program. The program is different in reception to year 1 to year 2, so that there is continuity as children progress through early years and into key stage 1, and get to the end of key stage 1 indeed. And so you will be repeating the program with your new intake. So the year 2 teachers will take children actually who've already had a year on the program, and hopefully you'll notice a real difference there. And year 1 teachers will be taking the reception children who are probably by now brilliant at subitizing. And so you'll need to adapt the program as you go through, but don't quicken up the pace too much. That time to really embed is invaluable to do that. So do look up this guide from EEF. It's very useful to support implementation, to ensure that your investment in this program reaps its benefits and is sustained over time. So just a few remarks to finish. Bit of a checklist for you, and hopefully you've already done this. So nominate a lead teacher for reception, year 1 and year 2. So you have 3 lead teachers in total. They may be the only teachers in year 2, year 1 and reception, and that's fine. But for many of you, you will have more than 1 teacher in each year group. And then that lead teacher should register on the Mastery Number website if you've not done so already. The link was sent to your whole teacher, your head teacher, but it's the individual teacher, the individual lead teachers who should do the self-registration on that site. And once you're registered on that site, you'll be able to download some PD materials, some pre-recorded materials, and work with the staff in your year group around them. The pre-recorded will be very much bespoke to the particular year group, and you'll be sharing reflections and engaging in discussion on the online community, as I just said. And the lead teachers only will attend the live training at the appropriate date and time, and then share that with others. It's really important that that you attend those live sessions. Unfortunately, we can't give you an alternative session, although we're running 150 sessions across the year. We can't move people around. There's too much administration involved in that with the huge numbers that we have. So the date and time is crucial. We don't take all teachers out at once. They will come at different times, either during the morning or during an afternoon, for just over an hour for each of those lead teachers for their particular phase. So the training will be phase specific. If, for example, the year 1 lead teacher has a hospital appointment on that day, obviously they need to go to their hospital appointment. But if they could they send somebody else instead, either the other year 1 teacher, if there is another one, or the subject leader, maybe if there isn't one. We would like commitment to this live training. Also, my last bullet point on there is that the subject leader, in conjunction with the head teacher, should incorporate the Mastery Number program into the school development plan. If it's going to really be effective, be sustained, have the maximum impact that it has the potential to do, then it needs to be involved in there. and also support for implementation. Some monitoring and evaluation within school as well will be important. Few final things. The materials are protected and only available to schools on the programme, so please don't give them out and share more widely. Engagement will be monitored, and we'll feed back to the DFE as to how schools are engaging with the materials. All schools will be asked to engage in the evaluation of the programme and provide us with some feedback. And then a few schools will be asked to engage in more detailed evaluations. So if you are asked to do that, we hope you'll say yes and support us with this programme, because actually we will refine and develop the programme as we go through the year and into next year. When you log on to a live session at the appropriate time with your appropriate Zoom link, please add your name, the name of your school, and we'll use this as a register then. Somebody will collect and tick off those that were present. Just before we finish, just a little note about delivery of rekenreks. They will arrive at some point during the autumn term. As you can imagine, a huge shipment of rekenreks, and particularly pandemic has caused delays in shipping, etc. But you can continue with the programme. You can get started if you've not started already, which I guess most of you haven't. You can get started with the programme. What we suggest you do is that you use a virtual rekenrek. There's lots of them online. You saw 2 different ones being used in the videos that we saw. The important thing is that children become familiar with the structure of the rekenrek, of seeing the 5s, of seeing the 5 and a bit, developing onto 10 and a bit. So children become familiar with that structure, and then once your rekenreks arrive, that great day of excitement, the children would already know how to use them and be able to, take them forward relatively quickly. So it's not a problem. You can get started with the programme and you can develop it, and you can develop the understanding of those structures, etc. And they should be coming at some point during the autumn term. We have ordered them in order of when you applied, so they will arrive in 3 different shipments, depending on whether you applied in the first window of application, the second window of application, or the third window of application, just to be fair to everybody. So to finish with, if you've seen me speak before, you may have realised I use this particular slide a lot. I had the privilege of meeting Michael Fullen, and he came and spoke. Michael Fullen is international expert in educational change, particularly working with the Biden government at the moment, and also works in a lot of third world countries pro bono to support the development of educational change. And he came and spoke to a group of people from the Maths Hub, and this is what he finished, and it really struck a chord with me. We've all in school been through a difficult time. I mean, I've got enormous respect for all of you out there for how you've coped and how you've kept the curriculum going, how you've provided support for children and parents, etc. It's just been absolutely phenomenal. We got to a stage where we take a breath and we move forward. And he said that actually the goal in moving forward and coming out of the pandemic is not just to end up with what we had before, but to end up with something significantly better than was the case in 2019. And I think this programme will contribute to that, which is why I'm so excited about it. It will involve all of us, thousands of schools out there, tens of thousands of teachers. But now I just want to finish and saying, let's move forward together and give our children the very best of what we can. Thanks, everybody. I'm really excited to be working with you all and touch base with you soon. Thank you. Bye-bye.